All right, well, let's get started on today's lesson. So you've seen what we're talking about today. We're talking about factors, we're talking about prime numbers, composite numbers. So a little break from multiplication and division. Well, it really is multiplication, isn't it? But let's take a look at this chart to get our brain warmed up. 3 times what is 9? 3 times 3 is 9. 4 times what is 16? 4 times 4 is 16. 5 times what is 45? 5 times 9 is 45. 6 times what is 42? 6 times 7 is 42. 7 times what's 56? 7 times 8 is 56. 9 times what is 72? 9 times 8 is 72. 6 times what is 54? 6 times 9 is 54. 7 times what is 63? 7 times 9 is 63. And 9 times what is 54? 9 times 6 is 54. Just gotta be fluent with these math problems. We've got to know them just like we know the back of our hand. We've got to know these facts. Practice them with your parents if you're having trouble with them. You know if you're having trouble with them since we've been doing division, especially because you don't know what times what equals the number you're looking for. So know your facts. Hey, let's practice some fluency with these. These are easy. 4 times 2 is 8. So what would 4 times 20 be? 4 times 2 is 8, and we add that 0, 80. 2 times 40. What's 2 times 4? 8. We add the 0, 80. 20 times 40. Uh-oh. Well, we've got that 2 times 4 still, and that's 8. And how many zeros? 1, 2. So there was not room to put that 800 in there. Let's see if I can scoot it over. No, it's 800. Just pretend maybe if I do that a little bit more. Well, anyway, that's 800, okay? 3 times 3 is 9. 3 times 30. 3 times 3 is 9 plus the 0 would be 90. 30 times 30, that's 3 times 3 is 9 with 1, 2 zeros again. That's going to do the same thing. That's 900, okay? 3 times 4 is 12. 3 times 40 is 3 times 4 is 12. And add that 1 0. And we're already off the page almost. 30 times 40, that's that 3 times 4 is 12. And add the 2 zeros. Yeah, so you know that's 1,200. This little chart just didn't work well. All right, well, let's get into looking at some of the things that we saw with Mr. Walker today. So the first thing we're doing is writing a multiplication sentence to represent these arrays. Just thinking about different ways we can represent the number 1, 2, 3, 4, 5, 6, 7, 8. So we know we've got 8 boxes here. So this is thinking about area model. 1 times how many? 1 times 8 boxes, right? So 1 times 8 is 8. This is set up differently, but we've still got 1, 2, 3, 4, 5, 6, 7, 8 boxes. Think area model. What's the length here? 2. What's the width? 1, 2, 3, 4. 2 times 4 is 8. So what are the factors of 8? Well, we've got 1, 2, 4, and 8. 1 times 8 is 8, and 2 times 4 is 8. Anything in the middle? We've got a 3 times anything, 8? No. So that's the factors of 8. 1 times 8 and 2 times 4. So 1, 2, 4, and 8 are the factors. Remember, factors are numbers that you can multiply together to get the number you're looking for 8. All right, so here we go. We've got another big 2 sets of arrays. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 boxes. So it's 1 box wide by 18 boxes long. So 1 times 18 is 18. When set up differently, we've got 2 boxes wide and 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes long. So 2 times 9 is 18. Okay, but now let's take a look at this. We've got 1, 2, 9, and 18. Are those all the factors of 18? Got a big space here in the middle, don't we, between 2 and 9? How about a 3? Is 3 times anything 18? Yep. 3 times 6 is 18. How about 4? 4 times anything 18? No. 4 times nothing. 5? No. And then we get back to 6. So here are our factors of 18. 1, 2, 3, 6, and 6, 9, and 18. We almost left out 3 and 6. So you got to be really careful to make sure you get all the factors listed. This is one way they told you could check. For this would be the 8. So you got 1 times 8, 2 times 4, 3 would be in the middle, 3 times nothing is 8. 8 for 18, 1 times 18, 2 times 9, excuse me, 3 times 6, we just looked at this, 4 times nothing is 18, and 5 times nothing is 18. The number's in the middle. So that's right. So how do they prove we found all the factors? Well, we've looked at the lowest number times the highest number and all the numbers in the middle and couldn't find any more. All right. Factors of 16, all the factors of 16. So we know we've got a 2 and an 8, but let's start with the obvious. We've got 1 and 16 factors, right? But then let's put that 2 and 8. Okay. Anything else? 3 times something 16? No. 4 times something 16? Yes. 4 times 4 is 16. 5 times anything? No. 6? No. 7? No. 8? We're already back to 8. So here are all the factors of 16 in order. 1, 2, 4, 8, and 16. All right. Let's go to the next one. Factors of 7. 1 times 7 is 7, so we know 1 and 7. Okay, 1 times 7, anything, there's a bunch of numbers in between there. 2 times anything, 7? No. 3 times anything, 7? 4? Nope. 5? Nope. 6? Nope. So the only factors of 7 are 1 and 7. What kind of number does that make 7? Makes it a prime number, doesn't it? Because the only thing you can multiply is 1 times itself to get it. So 7 is a prime number. And so is 5, because the only thing you can multiply to get 5 is 1 and 5. Can't multiply 2 times anything or 3 times anything or 4 times anything. So it's a prime number as well. Only 1 and itself. So 5 and 7 are called prime numbers. Prime numbers have exactly 2 factors, 1 and 5 and 1 and 7 for them. Brainstorm to fill in the table below. Can you think of some more numbers? So we know 5 is a prime number, 7 is a prime number. It looks like we're counting by odd numbers, 5, 7, 9. You think 9 would be? No, because 3 times 3 is 9. What about 8? No, 1 and 8 and 2 and 4. Let's go backwards. How about 3? Sometimes, yeah, 3 is a prime number. Okay, how about 9? No, we said 9, 10. 11. Yep, that's 1. 12. No, you got 1 and 12, 2 and 6, 3 and 4. 13. Yeah, that works. Only 1 times 13 gets you 13. So you see, you can list a bunch of prime numbers, who only have 2 factors. Composite numbers, more than 2 factors. Well, 4, because you have 1 times 4 and 2 times 2. 6, 1 times 6, 2 times 3. 8, 1 times 8, 2 times 4. 10, 1 times 10 and 2 times 5. 12, 1 times 12, 2 times 6, 3 times 4. How about 13? How about 14? 1 times 14, 2 times 7. So you get the idea. These have more than 2 factors. These have only 2 factors. All right, let's go to the next slide. So let's think of factor pairs for these three numbers. Okay. For 23, well, we know it's 1 times 23. Anything else? 2 times anything? 3, 4, 5, 6. I can't think of anything else that is 20 that would equal 23. So it's a prime number. What about 35? Well, 1 times 35. It's not an even number, so 2 times, I think, gives me 35. 3, no. 4, nope. 5, nope. What? Wait, 5? I think it can. If a number ends in a 5, you can multiply something by it to get a 5. 5 and 7. 5 times 7 is 35. 6, 7, 8, 9, 10. No. Here's the only factors pairs for 35. So it's composite because it has more than one pair of factors. 48. That's a big one. You've got 1 times 48. 2 times 24, 3 times 16, 4 times 12, 5, nope, 6, 6 times 8 is 48, 7, no, 8, we got 8 times 6, 9, 10, 11, and we're back to 12. So there's the factors for 48. Okay. Moving on. Oh, that's the last one. All right. So just a reminder, factors are numbers that multiply together to get the number you're looking for. So these have factor pairs. These are both composite because they have more than one pair of factors. A number like 23 is called a prime number because it only has one factor pair, 1 and itself. Okay? So your homework is just like this. You're going to tell if a number is prime or composite, and then you're going to be asked to list the factors. Not too bad. You can do it. Go get started.